it is with a special excitement, and I'm pleased to welcome Dr. Rupy Sawhney to our speaker series program today. Dr. Rupy Sawhney is a distinguished professor and Heath Fellow in Business and Engineering at the Department of Industrial and Systems Engineering with the University of Tennessee, Knoxville, and the founder of the Sawhney Solutions. He is an executive director for the Center of Advanced Systems Research and Education, CASR, where he leads a team of nearly 30 staff and grad students, very good students. Dr. Sawhney has developed the Sawhney model, which uniquely focuses on people-centered operational excellence strategies. This model is the basis of transformational projects and training programs for leading industries and federal partners, including the DOE, Covenant Health, and Clayton's Home, between others. Overall, Dr. Sawhney and his team has partnered with over 200 companies on operational excellence projects. Dr. Sawhney has established innovative educational and training programs with national and international visibility, including the on-site cohort program and the Lean Enterprise System program, both since 2011. The cohort program has graduated over 100 professionals with master's degree in industrial engineering, where the Lean Enterprise System program has graduated over 900 students from 10 different countries. Those efforts have resulted in a strong international collaboration with nearly 20 universities worldwide and counting. Dr. Sawhney has been recognized with various awards such as the Boeing Willie Bird Fellow, the Alcoa Faculty Award, the Institute of Industrial Engineering Lean Teaching Award, the Industrial and Operational Management Society Outstanding Educator Award, the 2019 University of Tennessee President's Award as the Educate Honoree, and the 2020 John L. Imhoff Global Excellence Award for Industrial Engineering Education. The title of his presentation today is Aligning Societal Health Based on Systems Engineering Design. I had a background of his February soccer team. I forgot to bring it up. Is it Manchester United?
It is. Watch this. No, I changed my hat for this meeting. I put the United hat on just a few minutes ago.
That is right. I'll set it up as soon as I finish here. Please join me in welcoming Dr. Rupy Sawhney.
Well, Dr. first of all, thank you. I think you've been too kind. Okay, you've been too kind, and you're a good friend. And I hope you and your family the best.
Thank you, sir.
So what we're going to do is shift over to the presentation. Guillermo, if you can shift over to the presentation. I think what we want to do is to talk to you about today a different philosophy about engineers. Okay, and if you talk to engineers about what they do, all right, I think to some extent it is very noble in what they do, but to some extent I think we minimize the impact of what we do for society. For example, what we do within industrial engineering, and more specifically within systems engineering, is to look at any kind of a system, decompose it, analyze it, and be able to put it together. A system can be a human being, a system can be a hospital, a system can be a manufacturing facility, a system can be anything. It can be a framework for immigration. So within that framework, one of the things that we want to bring out is this idea that engineering should not just be about engineering. It should be, in terms of, at least from our perspective, something to do with societal health. Guillermo, if you can take me to the next one. In industrial and systems engineering paradigm, we really focus in on the concept of productivity. I mean, everything, whether you look at the College of Business, you look at the College of Engineering, it's about this concept of how do I design something from engineering quickly? How do I get something operated on something quickly? How do I do something quickly? Okay. So the whole culture within the United States is based on this idea of competition, based on the idea of production, based on the fact that we want to be efficient and effective and be number one. But within that concept, when I look at engineers, and I think it's not just industrial engineers, it's all engineers, do we ever look at, from the process of how we design something, how we produce something, do we ever look at the impact that we have on societal health? All right, so those are the two decisions. Engineers, from an industrial engineering perspective, should not only be focusing on productivity. Engineers from other backgrounds should not only be looking at design, but it should look at what is the impact that we have on our societal health. If you can go on to the next slide. I think from my perspective, I can tell you that when we are looking at this idea of, is this our country the most productive in the nation? And we say that we teach in engineering and in business schools the concept of being productive. I believe to some extent, or in a large extent, we have failed. Where have we failed in terms of trying to do that? Every study that looks at different concepts, such as a concept of lean, okay, that's lean is how do I take a system and reorganize it and make it more efficient? Every study that looks at it tells us that when we do that, we in essence have failed in 50%, 60%, all the way to 95% of the times that we have touched systems and designed systems as engineers, that the ability for them is to sustain that productivity has failed. So when I design something and I go back a year later or 2 years later or 3 years later, the idea is that it's failed, right? And it's failed. So we failed at that particular thing. Yet we have disciplines that are putting people specifically to be able to be more productive. Yet history tells us that we're not really doing a good job. All right. So if you're going to go on the next slide, and we say, okay, how do we achieve these things? The US Bureau of Labor Statistics some years ago said that the United States has been productive. It has achieved productivity in whatever it does. But the three components that have led to this productivity is this idea of greater stress on the workforce. Second was automation. And the third is what we do. We design systems and that make improvement to it. Yet it was significantly number 3 in the list of things. But if you look at number 1, you look at the idea that as engineers, we are always have this concept that people are important, but none of our classes tells us anything about people or how to integrate people into our designs. Isn't that amazing? That if I asked any of your engineering students at this moment, I said, what is the most important asset that an organization has? When you're designing something, what are the most important assets that you have? When you're designing a operation, what are the most important assets that you have? You would say it's people. Yet I said, well, how exactly have you designed people into your product or service design? And the question is, do you have any classes that allow you to do it? And the question is, no, we don't. So exactly how are engineers prepared to look at the idea of not only looking at what they do, but to enhance the quality of life of people? So if you go to the next slide, I mean, and we're already there, I think, Jeremy, is who's the problem? The question is, we always raise our problem and say that our problem is somebody else, right? But is it possible that we as the engineers are the problem? If you go on to the next slide. My belief, and again, this is a slide that I designed some time ago, and I was reading a lot of stuff, and I said, how do engineers or other people make decisions? All right. And I said, well, it's based on their experience. What experience? Okay. And the first thing that came to me is, well, you know, they have a value system, and they learn this value system from their family and their cultural values and how they were raised. So I have a picture here that indicates two different people going to school. One, my God, you have buses and we better sit on the buses and everything must be it. And then there's another culture, the way you're brought up is hang on to the, to this truck. Hopefully you don't fall, but you're going to go to school. Cultural values, how you're brought up. The second is the concept of education. The people that educate you in high schools and middle schools and colleges and so forth down the line are people that are going to help you develop those experiences by which you're going to make decisions. But may I tell you, those are the same people, unless you traveled far, all right? Those are the same people that helped you raise you. They are the same type of things. So if I grew up in Tennessee and I went to school in Tennessee and I got, et cetera down the line, the values are going to be the same. And let me also tell you that if I was to make a decision on human beings, all right, that again, the educational system, at least from an engineering perspective, doesn't really do a good job. To say people are important, yet I don't have a single class that I talk about how to design people is an issue. All right, and then I go to work, and my God, it's the same thing. So what I learned from my families, what I learned from my educational system, what I learned from my work experience, that's fundamentally how I make decisions because of my experiences and the experiential learning that I have, and that's how I make my decisions. So these decisions are different. Next page, Jeremy. These decisions are different. These decisions are different. How? Depending on the proof that I have is this idea of arranged marriages. In certain parts of the world, like in India, you have individuals that get married because of who the family selects. Okay. Who the family selects, arranged marriage, and they call this arranged marriages. And in those countries, the marriages that we assume are normal here, they're called love marriages. So you ask individuals, and the thing that you find out is when you ask people in India, for example, and I did that when I was there about a year and a half ago, and I said, well, are arranged marriages valid? And the student responses were 70, yes, they're valid, neutral 20, not valid 10%. If I asked the faculty within that institution, it was 20% yes, valid, 80% yes, it was valid, and 20% neutral, and not a single person said zero. Zero said not valid. But then I do the same thing here in East Tennessee, and through the students and through the faculty responses, isn't it amazing that it is completely different? 100% of those individuals said that arranged marriages are not valid. Why that difference? The difference exists because of how we were brought up, who educated us, and where do we work. Go on to the next page. So I want to propose this and change it over to a little bit not about what life is all about, but a little bit about systems design. When you have a system design and when you're designing something, whether a product or a process, I want to understand from your background, the way unconsciously you think, do you think productivity is based on employee well-being, paradigm number one, or paradigm number two, productivity is based on employee effort? What do you believe? Not like, oh, I wish I was thinking this way. Inherently, the way you're brought up, whether through your family or your culture, whether it is through your classes that you have been taught, or is it through the work experiences that you have taught, what do you believe is the case? All right. Now, I want to show you a picture. This is a picture in two different worlds of people sitting. and watching work. These are people that are getting paid, but they're just sitting around. My question is, as an engineer that's going to make a decision about the people that work around you, that help you with the product design or the process design that you have, does that bother you? When you see people sitting there like that, does it bother you, and does it say, I better find them some work? If that's the case, and you don't ask the question whether, if they're sitting around for a few minutes or 10 minutes or so forth, maybe they'll come back as better employees and maybe they are better off. Then the question then becomes, is you believe in paradigm number 2, which says the way we achieve things is through effort. And therefore, everything that you do is based on effort. The way you look at things is based on effort. So here, as students in engineering, that's what you have to ask. Do you ever think of people? And does it bother you when people are just sitting around and drinking a cup of coffee and saying, well, let me talk to my buddy here for 5-10 minutes. Go on to the next one. If that's the case, then we, in essence, are the fundamental problem that exists. Not our engineering education, but the fact that our engineering education is incomplete from the perspective that we really do not understand how to integrate people into it. So take me to the slide back before this, Jeremy. So is there, in my world, in your world, a fundamental conflict that exists? Go on, please. Next slide, Jeremy. Okay. Here, I have if you would click onto this slide, an example of how Boeing has taken their 737, Boeing 737 facility in Renton, Washington, and redesigned it. On the top was what it used to be. I have fuselages coming in. I have stations for every plane. As I move the plane from one to the other station, I move one, I take one out and not set her down line. Well, it takes me 4 days from the time the fuselage comes in to the time that I actually go ahead and produce the plane. When I look at the bottom, that is what is currently done, and Boeing has actually started with the 737. And the reason I know that, I was there during that period of time in which the 737 was there, but they actually transferred it to the other Boeing models. And the second one is a moving line. The moving line is the planes don't stop. The planes move and the people come to that particular area and they actually work on it for a given period of time. So if you have 20 minutes or an hour where the plane is in your area, you can work on it. But once that is done, you're gone. I look at that design. I said, what a brilliant idea. Because rather than 4 days, from the time that I start to the time I finish, in 24 hours, I can get a plane out. What an engineering feat. And then if you notice, it used to be a warehouse. On the bottom, these are all engineering offices. And whenever the moving line stops, every engineer comes down and tries to figure out what the problem was, and they try to resolve it. But when I look at this line, I said, it's a moving line. It is moving to a drumbeat that says there's a pace by which it is running. Okay. 2, it has people that need to come on board, and from plane to plane, they do repetitive work. And 3, I can't really leave in the middle of my work and say, I need to rush over and get a cup of coffee, or I need to go to the restroom. And there are other attributes to it. But my God, we used to produce a plane every 4 days. I'm now able to produce a plane every day. All right. Go on to the next slide. This is a picture of one of these old movies. I think it was Moses or something like that. And Moses was captured and he was a slave. And what they did was they rowed boats from one area to another. And I look at the attributes associated with this guy rowing the boat. Is this guy rowing the boat according to a beat? The answer is yes. They were told you the pace, and when they told you the pace, that's how fast the boat would run. So everybody synchronously would row at the same rate, just like everybody who synchronously performs to the beat in the airplane. Does this person do a repetitive job and a routine job? The answer is yes. Very similar to what we did and assigned work to the people that were producing the airplane. Can this person get up and walk away? No, he's a slave. He can't walk away. Can he go get coffee? No, he can't go get a coffee. Can he go to the restroom? Not unless he has permission. Exactly the same attributes that exist in the airplane. So if in one case, engineers are designing systems to produce airplanes in that manner, yet the attributes as per in the individuals impacted are the same as what we would say is uncivilized. I mean, how can we have slaves and treat people like that, but the attributes are exactly the same? What is the difference then? That means the engineers that were designing these particular systems designed it from a technical perspective and did an outstanding job. But to be able to say that they included the quality of life of people, they absolutely did not. So those were exactly the same. And therefore, if you go to the next slide, there's a conflict between ideal operational systems and what ideal operational systems want, such as the Boeing, and what people want. And let me tell you what people want. And this we followed from Maslow's hierarchy, and we try to apply it to people that work. We said that the first thing that individuals want is security of a paycheck. I come to work and therefore I need to get paid because I need to pay bills. The second thing after they accomplish that is I want to work in a safe environment. And this environment should be physically safe, but emotionally and behaviorally and socially also to be safe. If I am a person of color, if I am a little bit overweight, if I am a person that has a particular sexual preference, I must not be treated differently. I need that safety. The third thing, after you achieve that, you look for it and you say, well, I've got that. I need a balance of life. That means I want to work, but I want to go raise a family and I want to do all the other things. The fourth thing that a person does once they have accomplished all that is, oh my God, what is the meaning of my work? Beyond the fact that I fill paper in, what is my meaning of my work? I need to be engaged and be involved. And the last thing is, I've achieved all of these things. Therefore, I want people, whether in a formal or in informal way, to acknowledge that I have achieved and I've given back. When we look at designs of Boeing, the fact that I look at the safety from an emotional perspective, I look at the balance of life, or I look at the various other components of what people want, those are never considered and in some cases violated, and therefore the conflict between systems and people. Would you go on, please? So can we learn? Can we learn from others? And I think there is something that we can learn. Go on to the next slide. This is a slide that really is two different sets of data that we got, and we plotted it. Okay. One was the productivity of a nation, and one was the amount of work that we do. So productivity of a nation is on the vertical axis. The work that people do, the amount of work that people do, in terms of time, workload, is on the horizontal axis. When we plot those out, isn't it amazing that the green are the most productive nations, yet they seem to work the least? The yellow are the next set of group of countries. They seem to work more than the green, and they're less productive. And then the red is countries that seem to have a lot of work. They do a lot of work, but they seem to be less productive. My question to you is, how is it possible to work less hours and be more productive? Because that's what this is showing us. And if that's the case, the idea that we think that if my paradigm is I must work harder, and therefore everybody must be doing something all the time, and therefore that's the way I'm going to design something, doesn't make a lot of sense. Go on. These are the top 10 countries in the world in terms of productivity. If you look at the US, other than Iceland, which is a anomaly, very small population, went out of nowhere and it came into this most productive nation. So if you take that out, you look at the United States, and it is one of the countries that is working the most. Go on. If you go to the next one, I don't think you can see this, that the first graph is work balance in terms of, oh my God, the work balance, how much time do I spend at work? How much time do I spend with my family? How much time do I to myself? How much time do I have to my friends? That balance of the top 10 countries, the United States is one of the worst. If I'm looking at this idea of percentage of paid population working over a threshold, that means working overtime, the United States is one of the worst. If you go on to the next. If I look at the most stressed countries, and I apologize, the United States is not there because it's the highest number on there, is the United States is one of the most stressed country of the top 10 countries. And if I look at health within the country and how healthy is the population, and by the measures that they have, the United States is by far the worst. How exactly is a country that is this productive, that has this many resources, not have a work-life balance, it's stressed, it is not a healthy population, okay? And when you look at Tennessee, for example, again, these are numbers that somebody gave me about a year, 2 years ago. 17% of the population is on opioid dependency. If you add on to these people that have physical, mental illnesses, the people that have addictions to drugs and alcohol, what percentage of our population do you think is currently not fully functional in the productivity of the nation? And if that is the case, that we have one of the largest percentage of populations that are not fully participating because of these issues, what do you think is the number one stressor? Do you think it is family? Do you think it is finances? Do you think it is health? Do you think it is work? According to what you have seen in the surveys, and I'm sure a lot of people have seen it, most of those have reported that the number one stressor of individuals that causes grievances for them is work and the way we have designed work. So therefore, you must tell me that from an engineering perspective, exactly how successful do you think we are? So we can design stuff, but how we design it, how do we get it done, in what manner needs to be done, is an issue that leaves us, wanting. And our motivation in our research is that we believe that over the long run, if we were to continue this idea of how we are running work within this thing without considering people and their quality of life, that over a period of time, that we are not going to be as productive, because a larger and larger proportion of our citizens are not going to be able to participate. And as you shrink the ability to work, what do you think is going to happen to the productivity of the nation? By how much do you think that you can push people beyond where they are being pushed? All right. So I want to introduce you to a model that we have developed and are developing at the University of Tennessee. All right. And I really don't want you to be able to say, okay, I understand everything. I want you to understand the essence of how it applies to you as being engineers. Go on. Click, Jeremy, click one more time. All right. Saw something in the back of a truck that says, if hard work pays, show me a rich donkey. Yeah, all right, I say, that's funny. But then if you look at what Edward Deming says, he says, your job is to help people do a better job with less effort. The very opposite of how you have been brought up. It is not the amount of work, it is the effectiveness of that work. Because majority of us, when we come to work, we can spend the time, but what percentage of the time do you think that you are actually being productive? All right, go on to the next slide. Therefore, our definition has changed. What we do is we design systems. Now watch this from an engineering perspective. I'm going to use verbiage that you may say, but this is not engineering. We are going to develop and enhance a culture that provides the greatest probability of achieving the values of an organization. The focus of an engineer, what are you talking about? You're focusing on a culture. To develop a culture that provides the greatest probability for an engineering firm to do engineering valued work. To look at a marketing company and let them do marketing valued work. To look at a philanthropic organization and let them do what that is, but to be able to develop a culture. And do you believe that you can impact the culture from an engineering perspective? And our answer is, yes, you can. It's just the way, that's not the way we think, and that's not the way we have been taught. Go on to the next slide. From our perspective, and I'm getting into some of the technical work now, we believe that we can redesign systems by technical stuff, and this is already done. Reduce cycle time, reduce inconsistency in the way we do it, reduce varied disruptions in the way we do it, okay? But look at this. The fourth principle that we have is we cannot achieve or make any changes to a system or a process and its design until we have evaluated and looked at the quality of life of the people. We simply can't. And my question is, for engineering students, how many projects have you done? How many reports have you written? How many exams have you taken where you actually address the people and the quality of life of their, of their life? And my assumption is, again, if you were like a student like me, the answer was 0. Yet, do you think as an engineering that we can impact that behavior? Go on. So we have developed a framework, and this framework really in essence has 4 modules. Module 1 and Module 2 are defining the problem. Module 3 is solving the problem. Module 4 is sustaining the solution. You said, well, this could be an industrial engineering problem. I'm saying to you, this framework is critical problem solving. It applies to every engineering. How do you define the problem? How do you solve the problem? And how do you sustain the solution? That's in essence what we're looking at. That we want our engineers to not only solve the problem or design the solution, we want them to define the problem. We want them to sustain the solution. And again, my question to you, and again, I would have the same questions for any student in any engineering. What percentage of time in classes have you already been given the problem? So therefore, you really don't have to define the problem. You just have to solve the problem, because I'm solving problem number 5 in the back of a book, okay, that was similar to the example that we did in the class. Our educational system does not promote the ability to really look at an unstructured problem and define the problem. And therefore, our students, our engineers that leave, struggle with this concept of, did I really know what the problem was that I needed to solve? But I think you're fabulous at solving the problem. And then sustaining the solution. Every time I've seen an engineering solution, it says, this is what I got, this is it, this is it, this is it, this is it, here it is. But never does it say how you're going to sustain it, for how long is it going to exist, or what environmental conditions is it going to give, what things are going to change where this solution no longer exists or is sustainable. How can we have engineering solutions that we're not good at defining and we're not good at sustaining, but we're good at solving? Right? So, if you go on to the next slide. We believe that the more you know about a problem, the less work you have to do. If I know where my problem exists, I can do it with one project. But if I have no clue of where the problem exists, I'll say, well, guys, let's try this and let's try this and let's try this and let's try this. And we have 4 different problems. And therefore, we increase the level of stress of people because we simply do not know how to be able to define the problem. If I don't know what the problem is and I'm under stress to be able to do it, I'll give everybody a job and say, go figure this out. Hopefully, of the 10 things we're doing, one of them is going to impact it. When we make changes, again, in a minute, I'm going to talk to you about it. I believe that we need to design systems. Okay, I'm talking about, the definition. I'm now going to goal number 3 for a minute. The definition of how the basis of the criteria by which we design things has to be reliability. Yet I know classes that we teach in engineering on reliability, more from a product perspective, but not from a system design perspective or a process perspective. And if I look at goal number 4, my God, I mean, as a student, I had never had a class that told me about people and the quality of life of people and how do I integrate them. So I may not be good at finding the problem. I may not be good at understanding reliability. And I may not be really good at looking at people. And then the question is, if we don't do that, how exactly do I classify myself as an engineer and I rank myself as an engineer from 1 to 10 and say, how good am I? Well, if the whole job is the description of defining the problem, solving and sustaining it, but I can only solve the problem really well, I'm not really that great an engineer. I may be excellent from a technical skill in solving it, but I really, in terms of societal impacts, I may not be the best. Go on. So we have a model based on theory of constraints, on something we call critical path. All right. And this process systematically allows me to go into any organization and physically identify what the problem is. Where previously, I simply, when I go into industry and I work with industry, they said, oh, I think the problem is this. Oh, I think the problem is this. This mechanism allows me to create a template in my mind that says, when somebody takes you to work, all right, can you define the problem? I've been in the past, in my history, been on consulting jobs. And what they do is when you have a consulting job, they'll take you in, they'll get you into the boardroom, they'll talk to you for a few minutes, tell you what it is that you're here for. They'll walk you around the area that they want you to take a look at. They may spend half an hour, 45 minutes doing that. But when you come in back into the boardroom, what they want you to know before you are hired as a consultant is, can you define the problem for you within that hour, 15 minutes or so? And if you do not have a template in your mind, then it becomes very hard to be able to do that. I look at graduate students, I look at people in industry, and one of the biggest areas that I find is they cannot define that particular problem. Okay, and so the next slide is, again, I'm not going to go through this with you, but what it does, it systematically lays out for those that want to do and say, I want to have a critical problem solving. It tells you exactly how to go about and define a particular problem. Okay. Now, for us, if you go on to the next slide, isn't it amazing that a system is always a system, a process is always a process, but we've never had a classification of these processes. And for us, one of the first things that we had to do was to be able to look at and say, okay, if I go into a company and I can find the critical path, that path in which there is a problem, okay? And if I can not only physically find the problem, but I can then categorize that problem into deterministic, stochastic, or Bayesian, is it possible? Is it possible? Again, I'm not going to go through what deterministic, stochastic, or Bayesian is. These are characteristics. And deterministic, for example, is a repeatable route in which you do the work, but it has very little variation in both the arrival times or the process times. Examples would be electronic assembly. Hospitals would be surgery, sterilization processes, and even simple surgeries that occur could be deterministic. Its solution is different than one that is stochastic or one that is Bayesian. Would it not be interesting for engineers not only be able to say, oh my God, let me physically locate where the problem is in a product or a service or a process, then be able to categorize it so that I can understand what strategy I need to be able to take on, go on. The strategy that we take on is illustrated here. When we, in industrial engineering, look at things, and I say I have a deterministic process, an assembly, an automated assembly line, I can fix that by designing the flow. I can fix that by looking at the level of inconsistency or variation that exists in that system, or I can fix it in terms of where things fail and they break apart, which is disruptions. When I'm looking at an automated assembly line, my God, I can't really change the flow. There's very little I can do about variation. Isn't it amazing that the first thing that I need to do is look at disruptions? Physically, I know where the problem is. I now notice it's deterministic, and therefore I can look at and then say, I want to fix the disruption. Stochastic, I first focus on variation, then on disruption. In a Bayesian, I would look at first the flow to minimize it, but really in essence, the variation and disruptions, and then I go back to the flow, which means that every design, when we look at it, we first have to stabilize the process and then design the flow through that process. The second thing that's important to me for engineers to understand is the value of their work. If I do something, what impact does it have to the organization? There was a process in many years ago, 7, 8 years ago, I was in Brazil, and we were working with a company called Embraer that makes airplanes. I'm sorry, Embraco, that was making things for refrigerators and appliances, things like that. Very large company. And they said, we have engineers that are working on a lot of stuff, but when they come up, the presentations look really good and the work they do is really good, but we really can't understand the impact that they're making on the overall outcome of our organization. So, and go on to the next slide. Okay, that's where we're talking. So we bring up this concept in our engineers that says things that you're working on are leading indicators. The things that they impact is throughput. And when you work on those things, then what you're doing is we're really, in essence, looking at lagging indicators that you're lagging. So if you say, I need my product to do this, just there's not a button that says the product must go faster. You have to have leading indicators that what component should I work on? Where should I work on? What should I do to that component? So this concept of leading and lagging indicators is very important. So an engineer must understand what are the leading indicators? Where do the leading indicators come from? They come from the definition of the problem as determinist, stochastic, or Bayesian. We find out what those leading indicators are, and then we move them up in terms of their impact. And if I look at the slide that you're looking at from an industrial engineering perspective, if I really want to increase the capacity and the capability of any process, okay, watch this. This is the way we want an engineer to think. That says, oh my God, if I need to, if it's deterministic, I may need to look at the maintenance of the equipment. If I need to look at the maintenance of the equipment, I may be able to look at MTTF or MTTR, which is mean time to failure or mean time to repair. This logic, in addition to physically identifying where the problem is, identifying what the strategy should be, an engineer must know what is the metrics that they're working on, and if I work on that metrics, what impact does it have to that product or that process, and therefore to the organization. All right, go on to the next slide. And in this slide, it's the same slide as we had before, except the only thing that we want to change is that we believe from our work, the fundamental criteria by which we do things is really reliability. The word efficiency is something we no longer use. Efficiency has a very bad connotation. We just don't like the word efficiency. When I say to you, you as a student are inefficient, I am transferring the fact and I'm implying the fact that you're not good at what you're doing. I have never said to you that I'm not a good instructor. I've never taken on that responsibility. I said, you are inefficient at doing that. That means, my God, I did everything I needed to do. You didn't do it. So therefore, we change our term to reliability, okay? And what we do is we look at it and say, what is reliability? Okay, if you would go on to the next slide. Reliability, in essence, is servant leadership. That means engineers should be, in my opinion, servant leaders. That means I'm going to design for you a product or a process that is reliable. Now, once it's reliable, that means now you have greater probability of success of getting your work done without putting a lot of effort in. From our perspective of looking at systems and processes, we transfer the reliability of a process into equipment reliability, material reliability, people reliability, or information and schedule. Because if I have people, materials, equipment, and schedules all brought to you when you want them, in the format you want them, in the time you need them, I've designed either a good product or a good service. And therefore, I have done my responsibility as a servant leader to provide you with the greatest probability of success. Okay. Go on to the next one. Now, how much time do we have, Guillermo?
There's about 7 minutes left until 4:30.
All right. The last thing that I want to cover with you, maybe one is simply, once we design the system based on reliability, once we define it, we understand what this impact is, we look at it and design it from a reliability perspective, we go back and say the following. Did we impact negatively an employee motivation? Separate motivation. What motivates it? You know, pay, security, et cetera, down the line. Did we impact negatively the engagement of the people? Did I design in my system the ability for that person to grow over a period of time? Did I allow them to make decisions in the system? And did I create an environment that when they come in every day, they feel valued? And then again, last thing is cultural alignment. When I design that system, if I design it in Japan or East Tennessee, it's going to be completely different because the cultural values are very different. Yet in engineering, we neither look at motivation, we neither look at engagement, nor do we look at cultural alignment. So because I've got 7 slides, if you would skip over and go into the case study. I wanted to show you a case study that we did for a mobile house manufacturing. We found out that the retention levels were at 50% when we started working, and they were producing about 7.5 units per day. Okay, I'm going to skip again, and what we did is we used our model. Again, I'm going to skip all of this, and what I'm going to show you is 2 results. One is, if you would go back 1 slide, all this means is currently they were not able to, the time that it took them to do stuff was a lot greater than when we designed it. So current is what the time that they would spend. The proposed is what we thought we could do. And then on the key areas, we piloted them and we showed that we can actually meet what we proposed. From a production perspective, we could possibly take them from 7.5 units to 10.5 units. Now, they didn't have a backlog at that time, so they've not done that, but they could have gone, and that's multiple millions of dollars. But more importantly is the next slide. We put Fitbits on every employee, before and after. And we found out that, for example, in station 1, where that a person takes 2,870 steps, we could reduce it to 1,310. And what we found out is that in almost every case, not only can we increase the productivity of that particular line from 7.5 to whatever it is, but every employee that we touch, we reduce the level of work on them. And therefore, we enhance the quality of life. And in addition to what we did and what the company did, which did a lot more work, the retention level of that company, of the people that want to stay at that company, went from around 50-some% to the last time I heard was around 95 or 96%. How do you take people's preferences and say, oh my God, I only want to stay at this company? 50% of the people stayed at the company. Now there's 95% of the people that stay in the company. It's the same work. They produce more, yet we put Fitbits on people to prove that we can actually reduce the physical fatigue on that individual. That's, in my opinion, what an engineer should do. We look at our specific domains of engineering, we apply our skill sets, but we apply them in such a way that we actually reduce the level of fatigue, mental or physical, on these individuals and enhance the quality of life. If we do that, we are, in my opinion, making us as relevant as I think engineers should be. Yet it gives you a sense of satisfaction that says, oh, I designed the machine. Oh, I designed that process. But for you to understand that this gives me a sense of pride to be able to say that our team went in and they could actually reduce the level of stress so that a person that goes home, that walks 8 miles a day at work, right, goes home only going 3 to 4 miles a day, that they have a better quality of life. That's what I think, and that's what I hope as part of this presentation is there for you. So we have, this next slide is simply a slide with some of the projects that we currently have or that we're finishing, all right? And then for those that are interested in this, please contact us and we'll share any information with you. Thank you.
Thank you so much, Dr. Sawhney. We definitely appreciate the presentation. And I'll let our attendees know that we might have time for one question or two. So feel free to use the chat box for questions, or you can raise your hand and I'll call on you. So feel free to do that. And I do have a question, came in offline. Wonder, Dr. Sawhney, your input or your insight about what students can do to develop the skill of defining a problem or practice in terms of defining a problem. What sort of things can they do?
Oh my God. One, I think simply the awareness that they may not be within a university concept because students are so used to being able to be given something and then doing it. So just have that sense of awareness. The second thing I would do is there are many different ways, places that kind of help you, give you a methodology that allow you to define a problem. So you could look that up, or you can call me and then you can see my number on it. I would definitely share what we do, how we do in a lot more depth so that you can understand how you can improve that.
Oh, appreciate that. Sorry about that. The question came in the chat. Do you think there is a perfect balance of productivity and prioritizing people?
The answer is yes. I think there is a perfect balance when you design a system, yet you don't negatively impact the quality of life of people. That's your balance. That's your threshold. The fact that you can actually enhance and improve their quality of life is that much greater, but the threshold is do not design a system that actually you either do not know or, that may negatively impact the quality of life, but at least be neutral.
Thank you so much for that. Appreciate that. And we had a question from Dr. Weigel about whether the slides would be available, and another asking about whether the recording will be available. And I can say the answer to both of those questions is yes, the slides will be part of the recording, and we may be able to make the slides available separately. I can talk to Dr. Sawhney about that. And it looks like those are our questions. So thank you so much, Dr. Sawhney, for your time and for this wonderful presentation. We appreciate it.
I appreciate your thing and thank you all. I hope you're all doing well and be safe.
Thank you, Dr. Sawhney. Have a great day.